Okay, students, this is Mr. Reef, and this is going to be a video about how to make a scatter plot in physics or AP Physics. I've got a set of data here. I've got age in months, and then I've got weight in pounds. Now, this is made-up data, but we'll talk about what it could mean if it were real data. So this, typically, the list on the left is the horizontal list, or in math they might call that the x values. And this, typically in physics, the list on the right is the vertical list, or the y list. So I'm going to go ahead and number my axes. I've got numbers from 1 to 8 here for the horizontal list, and up here on the grid I've got 2, 3, 4 here. So if I go by 2s, I will use most of the grid, and I won't go all the way to the edge. It's usually a little better if you don't go all the way to the edge. So I'm going to number by 2s down here and see if that looks okay. Okay, so I went to 8, and I'm going to label that A in months. Looks okay. Okay, so next I'm going to go to almost 17 on the vertical. So if I look over here, I think I need to go by 4s. 4, 6, 8, 12, 16. That's not going to be enough. Did I count correctly? Oh, I didn't. I went 4, 6, 8. 4, 8, 12, 16. Yeah, that will be enough. It will use most of the grid. And it will leave a little bit extra for my vertical list. I'm going to call that W in pounds. Then I'm just going to start plotting my points. So you're going to have to estimate possibly here. 1 is exactly in the middle between 0 and 2. So I'm going to go in the middle. I'm going to go up until I get close to 7. 7 would be above 6. This is 6, exactly in the middle between 4 and 8. Halfway there would be like right there. So I'll make a dot right there. 2 and 9.4. Well, 10 is halfway between 8 and 12. So this would be 2 and 10. 9 would be there, so I'll go up to maybe here. Hopefully that's in the right spot. Now I want to be at 3, exactly in the middle between 2 and 4, and 10.5. So I'm going to go up to 10 would be there, 11 would be there, so like 10 and a half is maybe right there. Next one is at 4 and 12. That's an easy one right there on that intersection. 5 and 13. So 14 is here. 13 is halfway between there. So right in the center of that little square looks right. 6 and 14.3. Well, 14 is exactly in the middle. So that's here. And a little more be like right there. 7. Halfway between 6 and 8, and 15.2. So that'll be more like that's in the middle. 15 is there, a little bit more. Seems about right. And then the last one is 8 and 16.7. So 16.7 is most of the way to 17, 7/10 of the way to 17. So we'll say like right there. Okay, now the next step, I'm going to even out my dots a little bit. It's good to make your dots very visible. Don't have to be super large, but they should be nice and dark and visible. And the next step is to draw a best fit line with a clear ruler. So I'm going to put the clear ruler on the grid, and I'm going to move this around until it matches the points fairly well, which should mean that if I have points above and below the line, I have the same number of points above as I have below and about the same distance. So if I do this, I've got like 1, 2, 3 points on the line, 2 points above and 2 points below. That doesn't look terrible. I'm kind of in a hurry here to make this video a reasonable amount of time, so I'm just going to go with this. I'm going to carefully draw a line all the way to the edges of the grid. Okay, so there's my line. Doesn't look bad. We're just going to use it. Now the next step is to calculate the slope. So the best way to calculate the slope is to look for places where the best fit line goes exactly through the grid marks. You do not want to use the points ever to calculate the slope unless the points are exactly on the line. So I see that there's a point here. I'm going to circle it. that goes right through two grid intersections. And then where's another one? This one is pretty close. I'm going to say this one goes right through two grid intersections. So I usually just label those points, figure out what they are. So this is between 4 and 6 is 5. So let's see. This grid is kind of working against me. 1, 2, 3, 4, 5. So that is 0.4 for each grid mark. So that's 5, and that would be 0.8 away, 5.2. That would be 5.2. I'm going to say that's 5.2. So I figured out, I estimated what that is. It looks like it's going to be 5.2 because 4.4, 4.8, 5.2 to there. And then these, so each one of these little distances from here to here is 0.4. And then in the vertical, it goes 5 to get to 4. So each one of those is 0.8. So this will be 12 plus 1.6 is 13.6. Now, those are the values for the first point, or this lower point that I marked. And then this one is exactly at 8. And it is at, I said these are worth 0.8 each. So that's 17.6. I'm not going to worry about units on those right now. I'm going to go over here and calculate my slope. So slope is always rise over run. And that is going to be the difference in the horizontal. So 8 minus 5.2, those are months, and 17.6 minus 13.6. So that will equal 4 over 2.8. And that would be in units of pounds over months. Now I want to get a decimal value for this, so I'm going to go over here to my calculator and get a value for those numbers, and that will be, well, I got some numbers on there. I had 4 over 2.8, so I'm going to do 4 divided by 2.8, and that is 1.42857. I'll just round it to 1.43. 3 digits are usually enough. So approximately equal to 1.43 pounds for every 1 month. So it looks like whatever animal or person is modeled by this graph is gaining 1.43 pounds every month. If we go over here, we also want to think about what this intercept would mean. That's 6 right there, so it's 6.8, looks like, which is really close to 7, which is the first value at 1 month. It looks like that is about 6.8 pounds, if I'm estimating correctly, and that would be, the intercept interpretation would be 6.8 pounds would be the weight at birth. And then over here, equation, correct variables in units, I'm going to write an equation that models this graph, and I'm going to say weight in pounds is equal to slope 1.43 pounds per month times age in months, I'm out of space here, plus 6.8 pounds. So I didn't leave myself enough room in this little box here. It'll be in a little shorter form. It'd be W equals 1.43A plus 6.8. The units are preferred, but that's just to simplify it. And remember, this is just slope-intercept form. Y equals mx plus b is how a math teacher might tell you that form is described. But specifically here, it's weight equals 1.43 pounds per month times the age in month plus 6.8 months, or 6.8 pounds, sorry. So this is an equation that models the growth of an organism like a baby human. I hope that's helpful. Thank you very much.